me show ourselves. Kevin, you got to come a little closer to me, bro. I won't bite you. There we go. We were talking about these proctoring sites and how you can use a little petroleum jelly or something. Blur your camera enough where it doesn't detect it, yet it still allows you to. I mean, if people are going to cheat, they're going to find a way to cheat. If anything, it made it even easier. At least in the classroom, we'd have to go and sit next to your buddy and look like that and pray that the class was big enough where you didn't get caught, right?
Yep.
I mean,
much bigger fear factor in the classroom.
When I was going to uni in like the late 80s, that was like, there was one class that it was astronomy, dude, and I couldn't learn the material. I wasn't going to class either, which didn't help. And on the final, I sat next to my roommate, and he literally just kind of kept the paper enough in view for me.
Just kind of nudged it that way.
Yeah, if it wasn't for Tony, I would not have passed that class. I may not be here today when I graduated. I mean, I'm not proud of it, but
desperate times.
No, but if you're telling me a little petroleum jelly is gonna blur the algorithms, I would think at this point they could identify that you don't have a crisp.
Yeah, even for example, like if you kind of cover.
Oh, they're saying that they can't hear us, bro. Let's bring that mic down a little bit. I've got far jelly or something.
I hear it on.
How about that? Maybe that's a little bit better.
I hear it on stream here.
Yeah, I thought it was pretty good. All right, so that should be better. And let me know if that's better or not. I'm also sitting back, which I normally don't. Oh, but I got a monitor right there, and that looks pretty good. Looks pretty good. Yeah, I could see how if I'm that far away, maybe I got to be closer.
Yeah.
I don't know. All right, that's fine. It doesn't really matter. Okay. Though we can't have your face blocked, Kevin. You're the pretty one in this group.
Oh.
All right. All right, that's fine. All right, so enough of that jibber jabber. What we need to do is go back to our notes. So Kevin has a keyboard today. I think we're going to have him drive, except he needs his mouse for everything, which drives me crazy. So, yeah, use your command tab, bring that up, and go to API services. Here in front ends. Whoa, why is foundation red?
Yeah, I had that on my end.
What? Okay, click on that because I don't.
It's an import.
Oh, we have to blockchain. Oh, so you have to change that to be whatever our project is, right? So right click on that and say get relative path, copy relative path. And then what you can do is, I think this project's Ardan Labs USDL, right?
Yep.
So change blockchain to USDL. And then you can just get rid of blockchain after foundation. No, just double click on blockchain. Yeah, hit save there. Huh. So
foundation signature.
Yeah, so that should have fixed
chat.
That. Oh yeah. We're in chat. You're right. I keep forgetting we're in chat. Okay, good. So how come that didn't go red for us yesterday?
I don't know. I saw it after the show.
Well, whatever. It was just an import issue, right? So that's not a problem. So save that. Let's clear that file out. Okay, so let's go back to our main. Let's take a look at our notes.
Yep.
So we have a hack program that we should review, which is going to give us all the code we need to do what we're now calling decentralized identity. It's not really auth in a
it's more like
right?
you are
who you are, right? And nobody can spoof you. So that was the idea there. We already switched over to using the Ethereum ID and stamp, right? We made that code change in the signature side. So now we got to implement this stuff in the client and the server, and then we said that to track the nonce, we'll create a small account ID. But we first have to start with our. Let's go back and look at our hack program under tooling.
Made that go.
All right, you might have to talk louder though, dude, because you are very for a guy that's as big as he is. He's very soft spoken. Okay. So, I didn't mean to take them out. I was just looking over here. All right. So let's scroll through this code real quick and see what we're doing.
Okay.
So we generated a private key, which we're going to have to, well, let's do the code on the client first, and then we'll do the server side. So our client code is going to have to check if there's a private key already. And if there isn't, it's going to have to create it. For the file path, I think we hard-coded and for anybody that's just jumping in, go back and look at Zarf again. We moved everything under Zarf, under cap and client, right?
Yeah.
So if you haven't done that, you're going to need to do that on the show here with our contacts. And
contacts was already done. Yeah.
Yeah, but all that, those IDs are all going to change by the time we're done here, right?
Yeah.
Even in the config and stuff. All right, so, and then that key is under client, which is good. That's where it belongs, right?
Yep.
Nobody, and Kevin just violated my private key, so there we go.
Oops.
So that's good. Or maybe I'm just really loud. I could be. I have a commanding voice. I can walk into a room and I don't need a mic sometimes. Okay, so go back to our hack program here. Okay, so we're going to have to write code to check if the key is there, and if not, we'll generate it, right? And we're just generating a key you can't lose. We talked about that last week. No mnemonics or anything like that. And we've got code already that looks to see if there's a config file. So we've got stuff to steal from. Then we're able to identify our public ID, and we should be able to, however we're doing we're going to have to write that to our ID file.
Okay.
So anytime we create a new private key, we'll probably have to write that there. Now, I might have to manually, so this is what I'm thinking, right? If I'm running into this problem right now, everybody's running into this problem. So I think what we're going to do is I'm going to delete my private key that's there when we get this working. And what we'll do is if we create a private key, then if you look under client, we have the ID, Zarf client, right? So under config, we have that user and all that. I might have to manually, so what we could do is, I'm trying to do it so nobody has to do anything manually, right?
Yeah, we want to avoid that.
But all those IDs are going to be off. But we might have to write some code where I think we're just going to have to delete that config and let it get recreated with the new key as well, right?
Yeah.
I think we're just going to have to do that. We're going to have to do that. Everybody following is going to have to sort of just delete those. In fact, we're going to have to delete everything that's under there and start over once this is all sort of done.
Gotcha.
Yeah.
Okay.
So why don't we just delete that now for me? Delete all of it.
Just the whole client?
Not client, but underneath client. Contacts, all three things. So you should be able to, just delete all of it. Because we're going to have to recreate it now when we do this work, right? So go back to the hack program for a second. So on the client side, we're going to generate that private key. We're going to use that as our ID to create the code we already have, which is sort of that config. And we've got that code between basically 22 and 38 to do that. And then anything that we now send, scroll down, we're going to have to write that code to sign it. Right? And we're going to have to send that stuff over as well. So we can do all that code. We won't be able to run it until we go to the server side, which will start on line 66 and take the data, use our signature package, and we'll get the ID, and then everything else should be able to work. And this is going to be at the cap level. So anytime the cap receives a message, right? Whether it's from a socket connection or from another cap, we're going to want to do that sort of check. The from ID is going to have to be in this data just as a second validation that we've got the right ID. So socket to cap, right? That message comes in. We're going to have to do the from, validate it, life is good. From cap to cap, because it went over NATs, we'll do that check again. That way nobody's spoofing us on the network. And then the question becomes, do we care about doing another check at the client level. I mean, at that point, your cap is insecure. So I don't think we have to worry about that there. I think we can trust.
Yeah.
We don't need to bring signatures back down to the client, right?
Got
I don't
it.
bring
Yeah.
signature down. We will have to pass the signatures around. Oh, Dom just jumped in, so that's pretty cool. So we will have to send signatures across the network, just again, in case somebody's trying to spoof us. But that's fine. So we've got a little bit of work to do. This might take the 2 hours.
Just to get that.
Just to get that working there. So let's scroll up on our hack program. So we know the very first thing that we have to do is the creation of all these files again, right?
Yeah.
So let's go to our client, front ends, client app, main, and let's see what happens in main again. So we had a sample config there, right?
Yep.
Why did we put that in main? Because if
I think people had to create it, so we just
yeah, right? Because if anything, go open up app. There should be we didn't call it config anymore. We called it what? Contacts. Right? Scroll up at the top of that so we can look at the, right? You have contacts, we have a new contact, and we have right contacts, and
no contacts.
yeah, scroll down. So mine, contacts, look up, scroll down, add, and then right. You see the right there? Yeah, right click on that real quick. We just got to refamiliarize again.
Yep.
Right, and that's unmarshalling the document. And if you hover over document, we can see the IntelliSense in the parameter, which is a doc user and all that, right? So if anything, if we wanted to keep that comment from main, we should put it at the top of contacts. Like if we really, but I don't think we need it, right? Let's just.
Well, it's going to change now, right?
The only thing that's going to change is the IDs are going to be a little bit larger.
Okay, because now the IDs will be the public keys.
Well, it will be that ID that we get from that address, right?
Yeah.
So, but get rid of this comment. Like, it was probably important at some point, but I don't think we need it anymore. Yeah. If you hit save, the Go Fumpt will fix all that. Okay. So in run, right, we do app new contacts. Then we get our ID. We get a new client. We do the handshake. So go into new contacts because this is where everything's going to have to happen here.
New contacts.
Now, in new contacts, we went ahead and we created the contacts folder if it didn't exist.
Yep.
We do this. We go and do a stat, and it says, oh, no, you got to create a config. So here's the thing. We're now in this path where we know we didn't have any contacts, which means we know that we didn't have any config.
Yeah.
Right? We should be able to do everything sort of in one shot here. So creating a config would also mean that we need a identity.
At that point.
Or we can separate that path and just say, but I mean, for our purposes here, if that's all empty, the whole thing, right, should be at a starting point. So we can simplify that a little bit. Let's go into create config. Let's see what happens in there. So I don't know if I want to separate the key from the config, right? But if you look here, okay, it's making a directory. If it exists on that, that's fine. And then it's creating a config. What did we pass into this function? Go back to where we were on the top. Yeah, so like command arrow would bring you right up. So your command arrow would bring you right up. And so when you see create config, it says file. File name is the joint of file path and config. And what is the config name? Hover over it. There must be a constant. So we hard-coded that, config.json. And the file path we passed in. So if you go back to main real quick, we can see that we've hard-coded that. So chat, zarf, client. Okay, let's go back to new again. And then we added contacts there. So the file path is contact. So that's what I'm saying, right? So ideally, we might really need a separate sort of path for identity. In other words, like that's new contacts, right? But we might need a new identity and then use it Basically steal some of this code here to do the identity piece. We wouldn't have to steal a lot. So why don't we add a new Go file?
An app?
Yeah, and call it ID.go. And let's see here. Oh, sorry, bro. I was.
Oh.
No, it's me. I gotta let go of it. And add it. Yeah, let's add a new ID.go. Fix that.
I messed up.
My daughter's calling me while we're in the middle of it, so I'm gonna ping her a little bit here while we're in session. In a meeting, Mandy. Okay, so no. Oh yeah, package app. And then if you go and look at contacts for a second, look at contacts. You go to the top, right? We have a type called contact. So why don't we create a type called ID,
Okay.
right? That will represent the ID. Now go back and look at the syntax there, right? We start with the keyword type.
Type, contact, sure.
Yeah.
Sorry about that.
And you'll have to use capital ID. Just like what it's doing is pretty good, right? Now, we need a field in there that represents the ID. I think that's fine for now.
A string.
Yeah, that's good. And we don't really have a name. This is all about decentralized identification, right? So that struct is fine. And then I would follow the same pattern we're using, where it would be like a new ID. But I think, is this really a new? Yeah, we might need a new ID, right? Because we don't necessarily have one.
Yeah, we
So
wouldn't have
why
one
don't
yet.
we write that code where we do a function new ID?
Get used to this keyboard.
Yeah, it's a new keyboard.
Function.
But, it was helping you before. Get rid of those parentheses there. It was helping you. Like new ID, returns an ID. It's data, right? And obviously we don't want to do the random stuff.
No.
And obviously we have to check whether the ID already exists. So go back to your contracts and you can see right away, what do? A make directory all.
So we want to do this with the ID and
Yeah, so I think we need a file path to know where this stuff is going. I think we need to do a lot of that code, right? So if it's me, I would probably steal all that code from 30 to 47 at least, maybe to start, and bring that into your ID. And also ask for a file path so yeah, get rid of that return and all that code, right?
yeah.
And then do the same thing, ask for a file path. Now notice we used capital P because we kind of do that in Go. Okay. Now, if you look at the first thing, it's about making a directory called contacts. Ideally, that's not the directory we want to make. We want to be in the file path itself, I think. Unless you want to create a separate folder under client called ID, which we could do, right?
But that would only hold your ID.
Well, it's for the client, so it would be your ID. But we have contacts under there. So let's do that. Let's just say ID, right? Save that. So now what you're doing is you're making sure there's a directory that's a folder there called ID.
Okay.
Now, remember how we had config file name? Go back to contacts. We had that as a constant up above. Scroll up. So let's steal that. And here we can give the ID sort of whatever name we're going to use. Now, if you go back to the hack program, we sort of did that. We called it what?
Key.
Yeah, so why don't we steal that plus the extension? Not the whole thing, just the file name. You have everything else. Yeah. And if you come back to ID, that could be our... You need to learn how to use this keyboard.
It's rough right now.
Yeah,
It's
because
a
that
little
keyboard,
smaller.
But I think maybe you take the keyboard out of that thing, it'll be a little easier. I don't know. But
We can try that. It's just it needs I need the mouse
Yeah.
in front.
what should we call that constant?
We could call it ID.
Yeah. But use lowercase because it doesn't need to be necessarily exported, right? So that's your
Got
ID file name. So let's fix line 18 now because
File name. Yep.
Okay, so that's going to be the name and the location for this, right?
Yep.
Now, I don't think we need line 20. So that's for reading and writing, but we're going to have the system generate it if it doesn't exist, right? If that ID doesn't exist, it's going to generate it. Now, also, it's then returning this sort of ID. So we also have to be able to read it. So instead of var doc document, maybe that is
ID or
ID maybe. I don't know. I don't know enough yet. It might be, right? In which case, that's what we're going to be returning. But let's just scroll down next. So now you do a stat. You're like, does this file exist?
yeah.
If it doesn't, then we should have a function called create.
ID.
Okay, so let's fix that. Even though it doesn't exist yet. And capital,
it's capital.
It's a Go thing.
Okay.
So like ID, JSON, HTTP, things that are kind of like acronyms.
You always.
It's a Go styling guide that came across with sort of.
Got it.
So I would assign ID to that because that's what we're going to end up doing, right? And on the other one, it probably should be called read
ID.
Yeah.
Now,
And same
would
thing.
it be better to call it key instead of ID because we're naming it key up here,
We could do that. How about create key ID? We'll give it a
or
little
just
bit.
ID, ECD?
What we're trying to do is get the ID. The fact that we're using ESCD keys may or may not particularly matter.
Okay.
But if you want to be more explicit, you can call that create key ID. And because everything's in the same package, that might sort of help. Yeah. And then read key ID. And then assign that to ID as well, even though we haven't written it yet.
Yep.
Right? And then you have, instead of config, we can have maybe ID there. And then you can return, always lowercase letters for errors. That's really important. And then the line that we don't have there would be to return the ID.
Yep.
Yeah. And then give me a line space because it's sort of a separate. And we don't return errors here, do we? Go back and look at your new.
No.
So we need to fix that because this could fail. So you want to put that in parentheses, ID, comma, error. It could fail.
Copilot messing me up.
Yeah, Copilot's hard sometimes. And then,
And then now these.
now, that one's fine because we haven't written that yet, but you're not returning nil anymore. You're going to return an empty ID. So that would be an ID with the open and closed parentheses, but capital because the type name is capital.
Parentheses or brackets?
Brackets.
Brackets,
But that's not the type name. What is the type name? Perfect. And now there you'll do your nil. See, Copilot's helping you there.
Yeah.
So this is the same pattern we've been using over and over again, right? Create the directory if it doesn't exist there. Does the file exist? If it does, if it doesn't, create it. If not, then read it. So now we could do the create.
Mm-hmm.
Now, what I would do is probably go back to contacts real quick.
Yep.
Right? Look at the create config function. Now, ours is going to be different, but you can almost steal line 254, right? Not all that code because all the code doesn't necessarily make sense.
Yeah.
Like if it was me, I would just steal line 254, go back to ID, and add that function there because we definitely need the file name, but we're not going to be returning a document. We're going to be returning an ID, and now we can open and close the function. So like it's a basic starting point. Now, this is Copilot stealing from contacts, and that's not right.
Yeah.
So ignore that, right? What I want you to do is go back to your hack program.
Okay.
Okay, everybody's saying that nobody can see the code screen because they've only been looking at us. Oh man, that's a bummer. Anyway, we haven't written much code. Oh man, I forgot I do this when I'm recording and Eric's like yells at me. Okay, so that's a bummer. All right, thank you, Casey, for sharing that. And a bunch of people have said it and I have not been listening because we've been coding. So go back to your ID.go and scroll up a little bit. So for all of you, finally, Actually, I can do this.
Yeah, you could
Um,
take control there.
What we decided to do is create an ID.go, and we're following the same pattern as we are with our contacts, all right, where we've got our new contacts. We're going to be able to do a new ID, and we're basically stealing the code that we've got for that. This is the pattern that we've been using over and over again to determine whether the file exists or not. And I deleted all my files under client. Everybody's going to have to do that as well. And I've got Kevin driving. So that's going to be a little slower today, but Kevin's got to learn. So we've got to, it's just like when I see those student drivers out on the street.
Yeah,
All right, we got to be
same
patient. So I apologize that we haven't had this up, that you've only had to look at me. But this is sort of where we're going, and we're stealing code from our hack program here. So let's go back to this, Kevin. You're going to drive again. So create ID. Okay, so if you go back to the hack program,
Yep.
right, we know that we need to make that call,
Generate
private key. Go into that because that's a function that we wrote in our little hack. So take all that code out of it. Just not the function itself. Take all that code out.
Okay.
Probably didn't need the return, right?
No,
Because
I'll
I
get
just
rid of
want the copy it again. Just those 3 blocks of code, and go back to your ID for a second, and let's drop that into our new function. So we know we need to do these things here. So the first, scroll up top too, because it helps people who are watching if we put as much code that we're working on at the top of the screen.
Got it.
So it's
taking
checking
file
to
name.
see if it already exists, right?
Yep.
And if it does already exist, then it just returns. So this is a problem now because this was returning the ID, right? So if it already exists, then we're going to need to call read, but do we want to do that? So this is where it sort of gets sort of complicated. But the question is, do we even have to check that it already exists? We already did that.
Well, we're doing
up
that
top.
here, and that's how we know.
So
what to
we can
call
get
it.
rid of that line of code. We don't need it.
This.
Yeah, that block. We can get rid of it. Okay, hit save on that.
Yep.
Okay, so it's not bringing in the import. So
The crypto.
So when that happens, we've got a couple things we can do. You can hit Shift Command P, Shift Command P, and do the reload window, and then just make any sort of code change there and put it back, and hit save.
There it is.
Okay, so when you're copying and pasting a lot, what happens sometimes is go please gets confused, and you just have to sort of reset.
Yeah.
Now here you're going to have to return a 0 valued ID again. Yeah, I'm seeing the comments. I know. I'm bad. Bad Bill. Bad Bill. Same thing there, right? You got to return an empty ID. Again, ID is data at this point, so we're not using pointer semantics. Now, however, we need to return the ID itself in this case.
Yes.
So actually, I like what it sort of did there. Tab that and let's take a look at that. But give me a line space because it's another statement. I want you to use line spaces as paragraphs, right?
Yeah.
So look what it did. It used the crypto public
key to address.
common, and it did that. I'm
Public key,
curious
public
though,
key.
in signature, do we have a function in signature that does that at all?
Pub key to address.
But that's based on data, right? We just
Yeah.
need the ID. Go back to our hack program for a second. And
Generate private key.
scroll back up because you see crypto public. Okay, so we did the same thing here.
Yeah.
All right, go back to ID. So
I don't know why that's not.
it's a different tabbing thing. So look at what you did here. We generated a key. We save it to that file name, and then we can return an ID. But no, so I hate this. I hate this more than anything.
Mm-hmm.
I don't like doing construction on a return if there's 2 parameters.
I agree.
So what I would prefer is that we don't do that, that we basically fix that, right? We create a value. Yeah. Put the comma at the end because that's what Go requires. No, not there. Yeah, on every field. And then do a return where we can return ID and nil. Oh, you have the nil there already, right?
Yeah, so we do.
Yeah. And then save that. It should fix. So for me, I'd rather do that than jumble all that. It's harder to read.
I agree.
Okay. The call to public to address is fine there. Now the question is, we want the hex string with that 0x in there. So that's
good.
good.
Okay, because that'll give it that.
Yeah, I'm sure if we go back to hack, we will have seen that I used it. I used it too.
Private key.
No, I just did ID there. Public. No. On line 37 is what I'm looking at.
Yeah, no, there's no.
Yeah, so maybe we don't use that, and we'll see what we have there. So go back to ID and don't use the hex function.
Got it.
I don't remember what that does. We can check.
Public key.
Oh,
string.
That's because it was probably used. Go back to hack for a second. Were we doing that in a? Oh yeah, we did string there. So let's use string.
Okay.
So let's use string for now. I don't remember what the difference is between string and hex, but string is fine. So look, we just created the key, right?
Okay.
So let's scroll back up, and what that now did is assigned the ID with the proper ID on the create.
Got it.
And that shouldn't run if the file didn't exist, right?
Mm-hmm.
So the next thing now is to do the read.
The read. Yep.
So
we can go in contacts again. And contact.
you'd have to scroll all the way to the bottom because that's where we were doing anything.
Right.
Yeah, so
read config.
Right, so there's an open we'd have to do. There wouldn't be a decode, but there'd have to be a function, and I'm sure we have it somewhere. But so yeah, we can steal that.
Yeah.
Ideally, you could really steal that line 40 because it's much more accurate now, and you just change it to say read. And then you can go back to the other code that you found and just take the open. Though there may be something that points there. So take the open.
Okay.
All right, come back. But now my guess is if we look at the crypto package, they may have a read already. So why don't you just do like a crypto dot and see if there's a, right? Because there was a save. Right, keep going. Maybe there's a read. That's RKL. Load. See, so we don't need the open. Get rid of that open call because that already takes.
So we don't need the.
You get rid of all that code. We need the load, and the load takes the file name.
Yep. Which one of those files?
And what is load return?
It returns the private key or an error.
Okay, so it'll be PK and an error.
Okay.
And then you do your error check normally underneath. You could steal like line 42 if you wanted, instead of typing it all, because it's the same. Yeah.
Oh.
Yeah, I do that all the time too.
Oh, again.
Well, here. So let's kill it, because it's going to keep coming up. And now steal that, drop it in there, and then just change the error message to load, like load ECDSA like we did on line 47. Okay, and get rid of the line space, right? We don't need that line space above. Yeah. Okay, so now that you have the PK, you know what to do. You could basically steal lines 50 through 54.
Yeah, because it's going to do the same thing.
It's basically the same thing, right?
But this is going to be...
Well, let's use the same variable name then, right? So instead of saying PK, look, this code decided to use private key.
Yeah.
We decided to use PK. So
instead...
let's stay consistent. Double click. You got to learn how to double click. Stop. I just want private key. That's the variable. Double click.
PK.
No. So now we're going to use PK down here, but private key up there. Consistency.
Okay. So now...
Let's just stick with private key.
Okay.
So instead of typing that, right, This is the one
Copy
place where I would have said double click, Command C, double click,
Yeah.
right? So remember, you don't have to be, this is hard to do when you're doing this, but your editor knows about these operators. So you can double click in between operators and we'll just take words. That's really fast. And I've tried to show you to Shift Command Arrow,
Shift Command
right?
Arrow.
I got to get you there, right? The Shift is a highlight. So if you just do Shift Arrow, you're doing one at a time. If you add the Shift with the command, you're doing lines at a time. There's even a way to do words at a time with Option, right?
Gotcha. Yeah.
Right? So Shift is your highlighter. Your arrow key is moving the cursor. And then you have command, full lines, options, words at a time. Ideally, you never see me use the mouse unless I'm doing something like I want to
moving
move
through
that
files
and stuff like that, right? And until you sit down one day and decide that this is the way I'm doing it, right? I'm not gonna pick up that mouse. You're gonna continue to sort of,
just
you gotta
rely on
fight through it. So get rid of that. I need a line space after 61. It's a separate concept. Okay, hit save. Constantly hit save. You shouldn't even be thinking about it. The moment your brain takes a break, you hit save. So now you have the read, right? Which also returns the ID. So go back up to top. Let's see what we got. So now we have the new, right?
Yep.
And the new will either read what's there or create a new key. Beautiful. So we now have a key. We'll test this out. But now go back to main. And if we look at this, it says app new client where it passes an ID. Well, guess what? Lines 28, 28 and 29, that sort of goes away now.
So we don't need this.
Now you're going to use your new app.newID. Look, it already, if you were looking, Copilot did a pretty good job there, didn't it?
Yep. And it's still
doing a pretty good job. Let it do that. Yeah, I like it. I like it. And just give me the carriage return line feed. Now, we don't have a name anymore, right? Because we're trying to be this, right, identity here.
Yeah. But we do have the ID. Well,
so the question is, do we need the name anymore? On the handshake side, we gave the name, but maybe what we should be doing on the handshake side is really the ID itself. So we'll take a look at that code. Okay. But now you have an ID. Okay. And this returns an app ID.
Okay.
So now the question is, should this take an ID or should it take an app ID? What do you think? Let's stay strong on the type system.
Yeah.
So let's change app new client to not take a string, but to take an app ID. No. I want to change the function. Right. Now it doesn't take a string anymore. It takes an ID. Now I would also argue, if you scroll up a little bit, that client shouldn't take an ID for the string. It should take a ID. And if you scroll up a little bit more, now that one might have to stay string because we're using it to maybe marshal and unmarshal stuff. And we don't need to make ID marshable at this point. I don't think we do. If we need that to be something that can be marshaled in and out, let's say we wanted to do that, okay? Because we want to keep these IDs strong, right? Like on line 21, let's change that to be an ID. On line 16, let's change that to be an ID. But we've got to be able to unmarshal this, okay?
Yeah.
So go back to your ID. ID.go.
ID.go.
Okay. Now, what we're going to have to do is add a method to allow the system to be able to marshal and unmarshal this properly. Now, I got to go look up a little bit of code to do that because off the top of my head, who remembers all that stuff? So let me go bring up real quick the service project. And what I'm going to show you here in the service project under types, okay? I'm sure we've got it here. Marshal text. So we're going to need to implement both Marshal and unmarshal, honestly. Let me see if I have a unmarshal as well. Okay, so that's cool. I have it here in, actually, I've got it here in error, right? So let me just steal this real quick. I'm going to steal this. I don't need this project open anymore. Okay, remember I told you all the code you've ever written is part of your toolbox, right?
Yep.
So I always like the factory function first. Then I like the method set. And then I'm going to put a line here because these are like unexported. They're just unexported functions. And I want to separate that. But
got it. Okay.
This is going to be our ID here, right? And again, we're using what? I'm just going to do this piece here. We're using, now this always has to be pointer semantics no matter what because it's an unmarshal call.
Yep.
Okay. So I'm going to let you drive again. So on the unmarshaling side, what that means is we got a string of bytes. But we know what those bytes are. They're a string. Look at what we did on line 42.
Yeah.
Okay. So if you really we can get rid of 44 through 47. We're not doing any map lookups. And I love what we did on line 46. So essentially you want to copy line 46, but instead of EC, it's the receiver variable. And instead of V, it's what's on the right side of the line 42, essentially, the string conversion.
Or
you could have just copied what we did there. Yeah, that whole thing from there to the end.
Yep.
That's it. Get rid of line 42 even. We don't need any of it. Everything can just move completely up. So that's essentially, oh, shoot. So it has to be an ID. So let's construct a new ID there. So instead of just the string, wait, watch. We need to construct an ID.
Oh, okay. And then give
right?
it the...
And the ID is...
Yep.
Yeah, right?
And give it the field. Yep.
And I don't remember where that field is, but it's still capital ID, right?
Yes.
So now what we're doing is we're essentially constructing an ID. We're saying the value that the pointer points to is this new ID. And it's just string marshaling there.
Got it.
And if you go back and look, and get rid of the comments because we're not using comments. So get rid of that, get rid of that. Okay. On this one, it's essentially the same. It's going to be ID, which is your variable or your field, capital. Remember, it's the field for ID.
Yep.
And that's already a string, right?
Mm-hmm.
Okay. Now, here's something that's super interesting. Scroll down a little bit.
And the marshal doesn't need to be pointer semantics?
No, because we're just taking the value and we're converting it into JSON. Even though you're seeing text here, the JSON, and we're not in JSON here, we're just converting it to a string at this point. But the JSON encoders will use text if it doesn't see Marshal JSON. It just gives you more flexibility with the encoders. So we're just essentially taking some bytes and we know that it's a string. But I want you to look at this for a second. What is public to address return?
Common address.
Right? So we've been using strings here, right? Mm-hmm. But if we even want to stay a little bit tighter,
safer,
right? If we want to be a little bit tighter in what we're doing here, instead of using a string, we could use a common address, which I would have thought we can find here.
Which is from...
This is all
crypto.
from
Go, yeah, okay.
Ethereum, right? And if you look at this, you can see a couple things. One, it's a slice. It's just an array of 20 bytes. Mm-hmm. And it also already knows how to
marshal
and
unmarshal
itself for whatever it is that we're doing. That's pretty cool, right?
Yeah.
And if we do this instead of a string, again, our type system is
safer,
much stronger.
Yeah.
Than a string can be anything, but an ID has to be sort of this, right? Mm-hmm. Now, I could make another argument. Do we even need this type? I mean, technically, isn't that, at the end of the day, sort of really what we need? right? Isn't this really what we need? And so we could make an argument that if I do that, all this code goes away.
Because it already knows how to do it.
I mean, we could leverage this. The question is, do we really have to abstract this type? That's the question. And my answer to that is why? Why abstract it? We could wrap it around our own ID and do that because one day we may not want to use this anymore as an ID, but we already said that we're using this for our identity system. So I could make an argument that instead of doing this sort of wrapping that we're doing, it already knows how to encrypt it already knows how to marshal itself, because that's what they're doing. And so what we could do is just switch to a common address. Oops. A common address everywhere. And just say, you know what? This is what an ID is. We're not gonna, doesn't have to be anything more than this. We can leverage this type. There's no reason to have the abstraction. And now what we gotta fix this. So now what this does is returns a common address.
Got it. Okay.
Right? And this, now could we have wrapped it in our own type? We could have, but I don't see any value in that right now.
You're abstracting something that's you're not really getting a lot of value.
We're not. We're just having to write more code and maintain it. And the only reason to do it is because you think one day you're not going to use this anymore for your IDs. But it would take no time to essentially get rid of common address and put something else there, honestly. So abstraction layers just create more work. It creates more mental models. It creates more things you've got to sort of keep track of. So unless you're absolutely knowing that in the future you're going to have another implementation of something or you're going to need the ability to swap that out. We knew at the beginning because we weren't going to stay there.
Yeah.
But we know we're staying here. So we've got that. Now, here's the interesting part. We've still got work to do on all these IDs here. But we're going to have to fix this to be able to run it. So just to fix this right now, just so we have something that's compiling, right? Because we're going to have to fix all this. But I don't want to fix it right now. Ideally, we don't want to be converting strings anywhere here. We want to be using what? Common address.
Common address, yeah.
All right, but I just want to get this to go... you see, that's already a common address, right? Because of the work we did.
So that needs to be common address.
For now. I'm just trying to get things to go green right now. We are far from this actually being where we want it. But I want to test that we can create the IDs. So if we don't fix these compiler errors right now, we won't be able to do that. Now, I don't care about the name, so we're just going to do that for now, okay?
App is screaming.
Probably because this is a string. And now this wants a...
Common address. Common address,
right?
Yeah.
So, and this is a string. So you see like this is a string. So even on this code here, we need to convert to a common address, right?
Mm-hmm.
So common dot, there's probably a function that does it, right? And it's probably this hex2 address is going to be my guess. But I'm just going to look. Yeah. So this hex2 address is going to be what we're going to need. Now, this is where things get complicated because I'm not going to remember if that's going to require the 0x in front of it or not. So we're going to see some problems with this, okay? But assuming that we get all that right at some point, at least that went yellow at this point.
Yeah.
There's a lot of work to do here, dude, okay? I mean, we're fundamentally, again, if I kept it string, we wouldn't have had these issues. But
it's not as strong.
It's not as strong of a we're trying to leverage the type system so we don't make any mistakes with addresses.
Yeah.
By doing this, there's no way an address that can sneak through the system that isn't at least within the scope of a 20-byte address. It gives us that protection, right?
Yeah.
So what do you now have? You have new ID, which at startup, we got our contacts. We've got our new ID.
Yep.
Now, I feel like this is somewhat, the new contacts has to read the config, right? Okay, so if we don't have a config, it creates a config.
Yep.
But that config, I guess, would be empty. I'm really curious about this one more time. Create config.
Create file name.
So this is bad, because what is it doing here? This is what I was worried about. If you're going to create a config, what do you need?
The ID.
You need a common address.
Yep.
Because
right now we're just doing a random.
I know,
a random
bad,
number.
right?
Yeah.
And we're going to have to test what hex does and what string does. But I think the string was giving us the 0x. And I think the hex was giving us everything other than that. So let's just use string. So name's anonymous. That's fair, right?
Because we had them go in and set their name.
So look,
right?
So this is what I was actually super interested in. We need to create the ID first. Okay?
Okay.
Because you can't do this, right? If we're going to have to pass the ID now, config path and the ID into new contacts.
Got it. Okay, so then contacts can add that. Yeah. Okay.
Can add that if a common address, right?
Yep.
Because if it's not there, then we can't really create it. And then the name is going to be anonymous. But now this is going to work in our favor, because now this creates a config using anonymous as the name, right?
Mm-hmm. Yep.
Okay. So come back here. In this case now, we could just say cfg dot my name. And if your name's anonymous, your name's anonymous. You can fix that all you want.
Until you
right?
change it. Okay.
Until you change it. And so now what we do is we've created an ID.
Yep.
We'll use that to create the contacts. If it's already there, now we could do something else. Now that we've got the ID, let's say somebody tried to hack your config or something, right?
Mm-hmm.
So we're reading it, right? So one thing we can do now is if doc.user ID doesn't equal that. Now we're using a string here for the ID, right? What should we be using?
Common address.
Should be using a common address. We shouldn't be using a string. This is where we're going to get in trouble again. Mm-hmm. But now what we can do if the ID in your config doesn't match this ID, which is the one we just read from your private key,
Yep.
We got a problem, right? We have a problem here. Now, again, we're going to see this until we can fix it all. But this user type requires a ID, a common address.
Common
That's
address
cool.
ID. Okay.
Our contacts is a set of doc users. Now, where is that type? Did we bring it down
Yeah,
here?
we brought it down.
So what
String.
should this be?
Common address.
Yeah, it's got to be a common address as well. Now, we know it already knows how to marshal and unmarshal itself. So we're going to be fine with this, all right? What's it? Something was at noon today. What was at noon today?
The meat.
Oh, that meat thing? Yeah, we can't do that. Okay, so that's kind of cool, right? Because now we have that, and this is a common address. That's a common address. We can compare those two. If they can, it's a mismatch. Mm-hmm. Now our contacts was a map string, right? Which was supposed to be the ID. Here's another really nice thing about not using string. This gives us clearer indication now from a code perspective that the key is an ID,
Okay.
right? That it's
I
an
see it.
ID. How nice is that? So once we start playing with these sort of stronger types, the code is going to get more readable too. But we're not just using types just to have a type. Like there's real function behind this type.
Yes.
So I don't like when people are just creating types with underlying types for readability. It never works. But here we're getting some value out of it.
Yeah.
Now, in this case, right, contacts is a map string. So let's go in and fix this. This is now a
Common address.
common address. That's what that is right there. Everything's going red because, we're switching out this string for that,
Yep.
which is fine. So now look it up. We're going to end up having to fix this just to get it to compile so we could test sort of the other stuff here. Yeah, I'm going to take this. And now it's just a matter. It's going to be mostly now changing the API to not use a string. Right? Now, join path, contacts, ID, dot. Now, this might be, we could use string too. That's fine. This might be a place where we may want to use hex. Because
Okay.
the file would be called 0x, but that's a fine, that file name is fine, right? So write message,
It takes ID as a string.
yeah, it takes an ID as a string, right? But it shouldn't. It needs to take ID as a common address, doesn't it?
Mm-hmm. And that is string.
That's fine. And what do we got? More red down here. And now
That's just ID.
it's getting better, right?
Yeah,
This is all
that's-
starting to get better as we try to get things to be compliant now with our new ID type, which is what we need to continue to do. Okay. Now this went all red because now we've got some of the same things we've got to do
ID
here.
is a string.
Yeah.
Oh, but that was the user one, which we wanted. Or
No, but
we're
that's
switching
fine.
it.
Everything needs to be
We're
a
switching it.
common address where ID is involved, right? And again, we're going to get the marshalling because the type already knows how to sort of do that. Now, what's going to happen though is, if our out message, which is a from here, let's go and look at this type. From is a user is a common address. So we've sort of, we did that already, right?
Yep.
Let me go back. Lookup is looking for us. Look, so that other stuff I did just to hold us is no longer valid anymore because we switched the API to what? Using now a common
address. Yeah.
which is what we wanted. So we inadvertently ended up getting back to that anyway. So that's kind of nice. Now I'm curious what app is all freaked out about.
Read message, ID.
Okay, read message, contacts read message, common ID. Let's go back. Were we doing a string there? No, we have an ID though. So where did the ID come from? The ID came from this. Okay,
ID
so this
string.
is where
Okay.
it's in that UI,
Mm-hmm.
right, as an ID. So we already know what we have to do here. This is going to be common, or we can say it like this. We need to turn it into the common, right? So
Yeah.
common dot, what was it?
Bytes to address or.
No, it was hex to,
Oh,
what was the other one we used here before?
is that address?
We need to get it, hex to hash.
Hexa hash?
Yeah.
Okay.
Which, why did it go to common address here? Hold on. Hex to hash, can't use it because, oh wait, we have a string, right?
Mm-hmm.
What did we do before? Hold on. Hex to hash given a string creates, that creates a common hash. We don't want hex to hash. We need hex to address.
That's what we used.
Yeah, that's what we used. Hex to address. Assuming that's being used right. Okay. Oops. Okay, so hex to address to get to the ID. But I think what we're going to have to do is put that into This is the address, right? And do this, address ID, to make all that work. Now, this requires a string, because we're writing it back. So that's fair, right? And adding it, that requires a string. So hopefully when we use string, this works. Now, look, returns an address with bytes value s. If s is larger than length, s will be cropped. So this is where we might get in trouble with 0x and not 0x prefixes.
Yes.
We won't know until we run it. So there's a chance that we might have to use hex here
Instead of string.
So we can sort of bring it back. I'm just letting you know that my guess is we're going to have those sorts of problems.
Yeah.
I mean, we could easily, look, let's go to our hack for a second, right? We have an ID here. That ID is common address, right? So when I ran this, we could do this, hex, right? So ID string, ID hex, right? Let's run the hack program again real quick.
Let's see what we get back.
Yeah, let's just see. Just copy relative path. Wrong one. So go run this. What do we get? They're identical.
Yeah.
So string and hex is giving us the same sort of output with the 0x. Okay. Now, which means to me I probably want to use hex instead of string. But that being said, where was the code that we just, this right here?
Yep.
Okay. So let's go back to hack for a second. So if I just take this and I give it, I have an ID, right? So if we do this, this is going to return, of course, you don't want to give me the import because why should you? Because, you know, you like slowing me down. Fine. But hex to address gives me the common address, right?
Yeah.
From dot print f. Let me just steal this. And this is ID, just call it 2 because I don't really care. Because ideally I'm just trying to do this, which is going to use string. But if it's the same, then we're good, right? Because it's going to convert it and then convert it back to basically a string. Okay, ID 2.
Yeah.
I know, but I see.
Oh, hold on. Above.
Let me clear it.
No, yeah. They're the same.
Yeah, but
No. That's capside.
oh,
This is
here
client.
it is. These three here.
Yeah.
Okay. So all that worked, right? Yeah, I got confused for a second. All that's working. So what this tells me, to be honest with you, is I think anywhere that we're doing, and it's not everywhere where it's just a 2 or something, but I think it's just going to be cleaner if we just use hex, is what I'm thinking. And just stick to the idea that we're getting a hex. And we know that it has the 0 sort of x to it, right?
Mm-hmm. We keep it consistent
Yeah.
throughout.
And you just stay, so that one's fine. And then,
ID dot string.
yeah, but I don't, this was our hack program, right? So I'm not worried about any of that.
From ID.
Okay, I think that's everywhere. If we see it anywhere else, we'll clean it up, right? But everything's like green again.
Mhm.
So well, for whatever that's worth.
That always feels nice.
It does, but like I don't know if that's gonna work. So let's just go back and look at this one more time now. So we got app new ID. We
Yep.
know what that's gonna do. It's gonna go and create an identification if you don't have one.
Yes.
We feel pretty good about that. And instead of creating our own ID type, we're just gonna use common address.
Yep.
And I think that will just streamline some of the work that we have to do here. And everything will take a common address now for that. So now we go back to main and we call new contacts and we pass in that ID that we're expecting. we either create it, which we will the first time, or we read it, and then we can double check that we got the same ID, which is cool. And then what we'll do is, if we read the config, create a config, we can read it. It would be empty anyway, and we can get the config back. Then we construct a new client, which will give us the socket connection.
Yes.
But right now, what I'm worried about is just these two things working, right? So I'm going to do a return here. Nil. Compiler's going to complain.
Mm-hmm.
That's fine, because this code is not reachable. That's okay. I just want to see this run up to that point and see what files we get.
Okay. I get
Right?
it. Yeah.
And in the make file, we had what? Run client, right?
Yes.
So if I just do make run client, fine, no errors, right?
Mm-hmm.
And now under client, what do we have? We have we got problems.
It did not go into the ID.
It didn't go into the ID folder. We don't have any contacts yet. I do have an ID there with anonymous. I love that.
Yes.
That is hex. We love that.
That
That's
looks-
exactly what we wanted. But it created the key here and not under ID.
So we have to go back into.
So we're going to do this all over again. Okay. And we're going to go back to new ID. And actually, let's go back to main and figure out
because
what happened.
it's taking the
So that's right, Zarf client.
client. Okay.
Okay. But all we did was put make directory. So it created the directory.
To the
That's
file
fair.
path.
However, now this should have been ID, right?
Okay.
Yeah, that's where we screwed that up. That would have put it where we wanted it. Now, the question is, we have the ID folder, right? Do we want to do the same thing with the config? So,
And put the config in its own folder.
yeah, maybe. Like, if you see this, we joined file path. We're kind of doing the same thing here. Like, this to me is the same bug, isn't it?
I think so because config is going.
Right? I mean, it's kind of the same bug.
Yeah.
We didn't put it in the same spot. That's the config. Let's run it again with these changes. See what happens. So now you have contacts, which has a config in there.
Got it.
Now you have an ID, which is there. But I don't know if I want... Do we want the contacts in there? I don't think so. I think we did this right. I think when we write the
Because contacts was an individual folder for each
Yeah, you see?
conversation.
Yeah, we did that here. So I don't think we really want that. Let's do this one more time. Just so we feel like this is right. I think that was right to just keep the file path. So if I run it again, your client config is at the root. I think that's fair.
Yep.
We have our ID there. I think that's fair to organize it. And then we don't have any contacts yet, but we'll have it there. So I like this. And I like that I now have this ID that is hex-based, and all that should work. Okay. So far, so good, right?
Yes.
And now we have this ability to create an ID. We also sort of changed already. Front ends, I'm just looking again. So the other thing that we did was to use common address for all of our ID stuff, right?
Yes.
So I don't see a place anymore where we are not using a common address. And we know the marshalling worked because we wouldn't have seen,
Yeah, we wouldn't have
This.
seen that. Yep.
right? Now, we could test that the unmarshalling works by doing one more thing here. We could just print line cfg dot my ID, right? And run this one more time. So there it is. So we also know that it could read it out of the unmarshalling,
Yes.
and we get back the same answer. Okay. So at this point, that's good. The new client will connect. I can change my name if I want in the handshake, and this would run. And we can assume at this point that that ID will now be associated with everything. If I just ran this code as is right now, it would work. Only because the server side still just takes whatever that string is.
It's
and
still
it can marshal it, right? So there's no reason to run it, but we know that at this level it would work just fine. I'm going to save this because we've got to do that next piece. But let's just save the work that we've got here.
push that up.
And we're just going to save, just creating the, what is it, EC DSA ID, right?
Yep.
Okay. Now, look what I didn't do. I didn't add some stuff.
Oh, because we added the ID.go
No, well,
and the new.
none of
then
this should be.
It's not tracked.
Yeah, none of that's tracked. But we added the new ID.go.
Yes.
Okay, we're not done yet. Because if we find the code that's sending a message, right? We've got a message that comes in. We're fine with that. That's the user. The out message is a user. So at this point, we know who it's from. We already have that, right? Here's the message. Here it's from. Now, the other problem, though, is the out message now needs to be signed.
Yes.
This is the part now where we need the nonce. It needs to be signed. I want to see where this is being used. So this code here, which is the handshake, when we read a message, out message. Okay, so this is coming into the client, this out message. I don't know why we called it out message. This is really a message from the cap, isn't it? If we're reading us off the socket connection, right? Then this is where things have gotten like super confusing all the time. The out message is really a message that came in from the cap. Let's call it cap message for a second, okay?
Yeah.
Now, if I look at that change, it came here, right? Can't let me edit that on line 113. Fine. So then on 113, cap message, right? And we know that this message came in from the cap. That's the only place that's used. I don't know why we didn't do that before. In message. Let's see where this is happening.
And it's in message.
The in message is the message that we're sending to the cap. Right?
Yes.
So I don't know what we were thinking in terms of.
Because we're still, we're from
Right,
the
we're on
client.
the client side here. So if anything, this is an outbound message, right?
Yes, from
Okay.
the point
Right.
of view.
So one would argue everything's a cap message now that I think about it. But I feel like we had this reversed on the client side, and we probably tried to keep it in sync with the cap side, and that's where we were getting sort of confused.
Because
right?
it's two different point of views. From
Right.
looking from server side and looking from client side.
Right, it's
That's
two
what
different
was-
point of views. So,
Yep.
Okay, I don't know what's going on now. Try to undo everything. Let's undo. I already pushed everything up. So this outbound message was really
From client.
was an inbound message, wasn't it? Right. It's inbound. Everything is cap communication, right?
Yes.
So what if I just do this for now? We'll call it inbound message. And I'll just rename this in message for now. Right? That's there. And then this is really, we'll rename this to outgoing message.
Okay.
Outgoing from the
Yeah.
client, right? And I just want to see where this gets used. It's the out message. So this is already a little bit better to me because from the client's point of view, this is the outgoing message. This is the, let's call this we're going to use the other language, incoming message, right?
Okay.
Okay, incoming message,
An outgoing
message
from
as it
client.
relates to the client. Now, we know on the outgoing message, this is where we need a couple things now to make this work.
Mm-hmm.
We want the from ID because I want the cap to check it,
Okay.
right? And now we have that. We have a message. We're going to need a nonce.
Yes. Oh, okay. So this, like in the diagram, this is the part.
Right. This is the outgoing. This is why I got confused because this is the outgoing message.
Okay.
Okay. And then what we need is the signature. Now, I'm going to go back and I know I'm driving again, but just let me drive for a little bit here. This is where on the signature side, we're going to have these three V, R, and S as big ints. I did this just so I could steal this code right here for a minute. So we're going to have V, R, and S. I'm going to hit enter on this.
Okay. I was
Yeah,
wondering
I'm
why.
just trying to set it up. And we'll JSON this as V, R, and S, right? V, R, and S. This is going to be our signature. Now, I want to look at something real quick. I'm going to go back and look at the blockchain project real quick. I want to double check to the extent, I think it's under foundation blockchain, right? When we were sending this stuff across the, actually, let's look at the app tooling, wallet, CLI, command, send. This is what I want to see. All right. So if I do new transaction, signed transaction, this is what I want to look at. What is a signed transaction on this thing? Okay, so you see VRS, all pointers to a big int.
Got
I
it,
just wanted to
okay.
double check that, just to make sure that I was on the right track here. All right, again, open up the toolbox a little bit.
Yeah. And why are they pointers to a big int?
Because that's the way the API works. When you
Okay.
construct a big int, you get a pointer to it. So that's how we're going to get it back.
Okay.
It is data, but the
That's
standard
where-
library
yeah.
implemented it using pointer semantics, so we're just going to have to stick to it. Anytime something's using pointer semantics, unless you do the research, okay, you need to stick with pointer semantics.
Yeah.
But you'll see that this entire API is using
It's all
pointer
using
semantics.
pointer.
Now, it might be safe to use pointer semantics, and I know I've read this stuff before, okay? But you start reading this, operations always take pointer semantics rather than int values, and each unique int value requires its own. You see, like, this was not a mistake. This was,
Yeah. This was
yeah.
purposeful.
So we can't just switch to using value semantics, like I do with the mail address package.
Mm-hmm.
This is, so look, this is the new outgoing message. The from, the to, the message, a nonce, which right now we'll just set to 1 every time. We'll fix that.
Got it.
And then a signature. Okay, this is what we need for an outgoing message moving forward. All right. Now, we don't need it for the incoming message. We're gonna, again, assume that everything was done at the cap level.
It already got checked. by
Like
the time
everything
it
was
gets there.
checked, right?
Okay.
So now on this send, we have to construct this thing. Okay. So we need the from. I only have the to, but we know the from because the client should have the from. That should be our ID because when we create the client, we say who we are, right?
Got it. Yeah.
For now, the nonce is, we're just going to make it 1. Let's not worry about nonce just yet. We know we need it. Now the signature stuff comes in. So this should come from our signature package. So we have a sign function. Now, the sign function takes the message,
Okay.
but it needs the private key.
Yes.
So that's going to mean that when the client gets constructed, it needs the private key. Let's go back and look at main for a second. Now, we know something here. When we create a new ID,
Yeah.
it has to go and read the, has to go get the private key.
Yes.
Agreed?
Yes.
So the question is, the client is going to need the private key in order to sign everything. So one thing we could do, because we're here already, is change this to return the private key.
So now it's going to return 3 things.
It could. This is one way we could do it. I always look at initialization. Has something already done this work? Because if it has, there's no reason to do it again.
Yeah, we don't need to.
We don't want to be, should client have any understanding of private keys at this point? No. A big mistake somebody would make is just have client on construction read the private key. That's a mistake. It's not the job of client to do that. It's the job of ID.
Yes.
Even though we've put all this in one package, we shouldn't think that it can leak across, right, these program boundaries.
Yes.
Now, we could add another API here to get the private key, but we're already getting it here. So, in other words, we could just do this. All right. Change these functions to also return
The private key as well.
private key as well, because as you see, it already has it, right? And then we don't need another API to do what we've already sort of done. And that's why it's nice to have all that initialization in main to the extent possible, because then you can look to see, do I have this already? And I knew we had it already because you needed it in order for either of these APIs to work. So now we have the private key as part of that call. And now what we can do is when we construct a new client, right, we give them our ID, we give them the private key so we can work with the signature package. Okay. I'm stealing that just to make my life a little easier. There it is. And now when I go to new client,
New clients.
I like putting this stuff up front, to be honest with you. Private key. I'm spelling out private key because I don't want somebody, if we just do PK here, I mean, we can read it here.
Yeah.
But on the other side, you might think, well, it must have been a public key.
Oh, yeah, I can see that.
It really wasn't a public key, right? Since I've made it the second parameter, I'm going to keep the order.
Consistent.
So now we've got a private key for everything that we're doing, right?
Yep.
So now what we're going to pass here is C dot private key. Now our client loads the private key in memory, but it's a client app. It's not out in the server. Like, we can go down a whole other path of potential problems, but I think we're going to be fine with what we're doing here. Okay, so in this case now, what do we get back? We get back our V, R, S, or an error, right? V, R, S, or an error. All right, if there's an error, we have that. But now we have what? V, R, S. Nice. Okay, we're now signing the data first using the Ethereum mechanics that we looked at last week. And this
Okay.
easily could work, right?
On the first.
Well, we're going to make some cap changes here,
Yeah.
but
The server side.
I'm feeling better now that we use the hex function to do some other things. But again, this is all going to be marshaled for us anyway. So remember, though, when we do this part in JavaScript, right, the way JavaScript marshals big ints is different the way Go unmarshals big ints. And I had to write
Okay.
that special code to get rid of quotes
Oh, yeah.
because
yeah.
Go treats this as an int value. But on the JavaScript side, it was treated like a string. It's ugly. But anyway, so good. You want to send something, you got to sign it. Boom, unmarshal, bot, you. Okay. I love all this code. I think this is good. So now we've got IDs, we've got our contacts, we got our private key that we now pass into our client. And even my name right now is anonymous, but I can just go in there already
And change your name.
Change it to Bill K, right? Good. And that's up to you to decide what you want to do or not. And beautiful. And it reads that anyway from the config.
So what's stopping someone from naming themselves Bill K also?
The whole point is that this is right? This is distributed identity. I mean, not distributed, decentralized identity. The thing is I can be anybody I want to be. That's my handle at the end of the day. Instead of name, we could call that handle, right?
Yeah.
It's your handle. People use handles all the time to protect themselves. So, I mean, I'm not going to do that, but we could have called it handle, and then what your question wouldn't have come up.
Got it.
So what do I care? Like,
Yeah, I can be Bill K, but I'm
You
not
can.
the real Bill K.
no, but the same thing happens on Twitter, and that's why they used to go through a process of. But nobody could ever send a message with your ID,
Okay.
and that's the point. Because in order for you to send a message to me, I have to give you my
The
ID,
yeah.
and you're going to write my name in your contact list anyway.
True.
So
Yeah,
we
okay.
use what's in your contact list above what I'm sending anyway, right? So,
That's true.
And we might even be able to just pull name out of that at some point. Like, I don't know if there's any value in me having my handle name here anymore. Let's get all this coded, and then we can go back and check. Maybe at the end of the day, like, we don't need this.
So
Because
then,
you're going to have your own name for me.
oh, okay. 'cause
I
you're
remember
gonna write
writing logic that said if this was empty or something, or if you had it, use it. If not, take what was over the wire.
Got it.
So I get to say who I am from a handle perspective, but if you can override that in your own config, that's kind of what we did, right?
Yeah.
So when the message comes in on your side, you know it's Bill Kennedy, but nobody else knows necessarily
Yeah, that you're.
if they found my ID or something, right? It's the same thing with your phone list, right?
Yeah, you get a phone number and then you
I put
whatever
mom.
name.
I don't put Carmela Kennedy from
Yeah.
I put mom, right? So, okay. Let's okay, so I don't need you anymore. This is our thing here. Get status. All right. So I think these are the final commitment. I think these are the sort of final client changes, right?
Mm-hmm.
All right. So now we're going to do the cap side, which I think is going to be a little easier. Okay. So on the cap side, what happens here? I got to go back to this. You're still going to have your cap ID. That's fine. We open that, we read it, we parse it. We connect to Natch. That's not a big deal. Chat new. This is probably where we need to be because then the rest is we have chat new, and then we've got this. So we have a chat domain, which has the connect, which establishes a socket connection, right? And then it goes to a listen socket. Okay. Then a listen socket. All right. This is where we read that outbound message, right?
Yes.
Now, this says read message from, and it returns back a message. From is a user, which represents the from. Let's go back and look at this real quick. The handshake created the information we needed about that user.
Got it.
So
Okay.
from is just telling us the ID, but this is really the ID of the cap, though, isn't it? You see, that's a problem, I think. I think this is also where we're getting. Oh, no, but this is the cap. So that's the user connecting to the cap.
Yes.
Right. So that's my ID. So let's fix this now. So that user, the ID shouldn't be a string. It should be a common address.
Yeah.
Okay, that's fine. And then also, we're going to get
The two IDs, common address.
so an in message, that's going to change.
Yes.
The cap ID can stay UUID, but all this is going to change. And all this is going to change. So we have an out message. We like that. But the in message now, let's go back to client here. Let me steal all this for a second. Because that was the outgoing, right?
Yep. Outgoing from the client,
Yeah, model.
which is going to be incoming from the
Yeah.
cap's point of view.
I think so. Yeah. So the in, all right, the in message, and we can do the same thing. We can rename this as,
Incoming.
we called it incoming, right?
I think so. Incoming and outgoing.
Outgoing and incoming. So let's just say we do the same thing. Get your incoming message, and you got your outgoing message. All right. Incoming message, outgoing message. But using common, are we using more memory? I agree. It's only 20 bytes. So
Is it worth the loss of type safety?
yeah, first of all, it's 20 bytes.
Yeah.
And the string that we're using, I forgot how many characters it is. The string might actually be larger than using these 20 bytes if we counted. But the type safetiness is everything. So we don't want people just fudging any string and breaking things. So, integrity comes at a cost. I say this all the time. Go has 0 value. That's not free. You have to run electrons through the machine to flip those bits.
Yeah.
So if you want integrity, you got to pay for it. It's not free. Now, if we took a look at the string that we produced, and I don't have an output like this string here, right? Is that assuming that there are, I highlighted 42. So technically that's 42 bytes, isn't it? So using the string is going to be larger than just an array of, plus in memory it's larger too, because now you got the string structure, you got the backing array.
Yes.
That means you've got allocations. By using a common address, we're also saving on allocations everywhere because we know the size of this at compile time. So in all reality, using common address is giving us type safetiness.
Yes.
It's giving us efficiency. It's reducing allocations. It's doing a lot, right?
Yeah.
Yeah.
It's a powerful.
Yeah,
little
it's a
change
really
there.
powerful change in terms of everything that we're doing. It was a good question. Okay, that's the incoming message now, right? Bop, bop. Oh, whoa. Where is the from? From model. Okay, this is the incoming message. Now, this is super important. Let's come back here for a second. We got to double check something here. Actually, we did this wrong. We got to fix this. We're not signing the right data. Okay, we're only signing the message. That's bad. We need to sign all of this.
All of it. Yeah.
Just that. So we're going to need, yeah, we did, that was bad, right? Let's just call this data to sign for a minute. And that struct, man, that was bad. Nobody caught it. Well, I caught it, so that's good enough. Is this. Okay. That's the data that we need to sign. And in fact, what we're going to have here is essentially this, nonce one. Okay.
Got it. Okay, and then down here is just what we're basically adding in.
That's the
Okay.
data that we need to sign,
Okay. Yeah.
or it doesn't work at all. That's what the signature is going to be based on. Sort of right there. If not, none of this works, right?
Mhm.
And again, we got to play with the nonce a little bit. But if we just signed the message, it wouldn't be enough. We've got to sign these 4 pieces of data. And then our signature is based on that. Because we're going to take the same data and we're going to do it on the other side. So now that we do that, I come back here. And we've got our model here, right? This is the
Yep.
incoming message. Okay. So now users are complaining probably because this needs to be a
Common address now.
address now. And this needs to
Same
be
there.
a common address now. And user ID needs to be a
Common address.
common address. I have something in the clipboard, and so I don't want to. That's why I'm typing this. All right, and then
The connection. That's.
no, that's fine.
Yeah.
M needs to be a common address. Okay, so that should have taken. Oh, we got 2 more.
Oh no, Matt. That up there.
Common address. What else? I see one more red here. M. Yeah.
Yeah. Okay.
Common address. Okay, you're yellow again. Now, on the handshake, that's fine. That's fine. That's fine. We pong the user ID hex, right? That pong.
Okay.
Now, pong is part of chat, right? So we could. What is pong?
And Pong is taking in.
We
an
own that
ID
function, right?
String. Yeah.
Common address. Update last pong. We own that one. I would have thought that went.
All of that. Yep. Common address.
I shouldn't have bothered keeping that in the clipboard. with all this happening. Okay, so that's fine. Oh, so all that went yellow. And now I'm worried about the incoming message, right? That's happening. So we got to find that code right there.
Read message, incoming message.
Okay, here's the incoming message.
Yep.
Here's the unmarshal. Okay, this is the message that we got. Okay,
Mm-hmm.
from. We know who it was from, but we needed it in here anyway. Oh, we already know who it's from. We already know who it's from because when we established the socket connection, we got the from,
Okay.
right?
Yeah.
Okay, so let's do the following then. Let's get rid of from. We don't need it here. And let's get rid of from again. We don't need it. We already have it. And it's safer this way too, right?
Yeah. It keeps
Yeah.
them separated.
I think so. Oh, wait. What did I just do? Oh, yeah, outgoing message. Okay. Yeah, I expected something to go red because I didn't do this. Okay. So now it's the to, the message, and the nonce, right?
Yep.
That's enough data to sign. Which now, again, let's come back here. We're not going to have to bring in the from. We already solved that problem. That's the incoming message. So now we get the incoming message, right?
Mm-hmm.
Okay. Now we have to steal this same code here. Okay. So this was the data that was signed. Okay.
Got it.
Data let's just say that was, let's be a little JavaScript for a second. I mean Java for a second. Data that was signed, okay? So the 2 is this, the message is this,
This is a
and the
message.
nonce, we're gonna also, we get, so in message,
Dot nonce.
message nonce. So this is the data. Now, if we go back to our signature package, right?
Yeah.
There is a function that we need, and it's not from a, oh, we have the signature. Let's go back to the hack again real quick. Just want to double check something here. Oh yeah, we just use our from address. So,
Let me steal that.
so now we have the data that was signed.
So now this is our part where we're kind of unraveling that to get to
Yes.
the actual data.
This is us making sure that this came from who they say they were,
Got it.
right? That's your S. And now, if that fails, we're going to have to do this. And local unmarshal, but local signature check error, right? That's bad. And then we have this ID, and now what I want to do is the triple check, right?
Mm-hmm.
If ID
It's not the same as.
as the from ID. Now ID is a string here. So we could check this at a,
Because that returns it as a string. Okay.
yeah, it returns it as a string, right? Which is fine. So we could just do this with string check here. That's fine. Okay. And maybe I'll just call this here from address as the failure here. And here's the signature check. So this is the key to everything that we've been sort of trying to do here.
Yes.
Because now when the message comes in off the socket, which I sent, we're going to take the same data that was signed
Mm-hmm.
with the signature,
Yep.
and we should get back the same ID. And if we don't, then we know that wasn't from that person,
Got it.
right? Somebody's, we can even test that. Now, we have to do the same thing for the cap to cap stuff. I'm going to steal this code. So this was listen socket.
Yes.
We have something called listen bus.
Yeah.
Okay. So we have to send it. We haven't finished this work actually yet. Actually, let's go back to the model because here's the bus message, right? The bus message is gonna need this as well.
Bus message is what the bus is
From
receiving.
bus to bus.
Okay, from bus. Okay.
So we're gonna have to send that as well, right?
Yeah.
You know, we have cap ID from name to, again, I don't know if we need the name anymore, but message nonce, everything has to go back out. All right. Like one could argue that all this is always the same. We could use embedding here,
Yeah.
right? And just say, we're adding a cap ID and the from ID and the from name. Oh yeah, we have to do that, right? And then everything related to the incoming message is going out.
Got it. Okay. Yeah.
So now we got to look at where we're doing, and I'm glad I did this because that broke some stuff, which is fine. So this is listen bus, okay? So on listen bus, again, we have to sign the same data. So on listen bus, that means a message came in over the wire. Now, when that message came in over the wire, we needed the 2. So that is from the, that's your 2, right? Even though I do the embedding, by the way, all those
Yeah.
fields promote up.
Yes.
Yeah, okay. So I can just say that. I can say this, I can say nonce. We can do this here, and this becomes bus but it also becomes a return.
And
Okay.
all of those in message become bus. And promote.
And then our from is this.
Bus message from ID.
And
To
that can
hex.
be hex. Yeah, you got it, bro. This, and this is a return. And then now we've got on the listen bus also validating that the signature is valid between bus checks. And if not, we just throw it out. Somebody's trying to hack. And then we've got to do this one more time. The last time we do this is, oh, no, we got to fix the send when we send it on the bus. Okay, which is right here. Okay, send bus. So now on the send bus, this is going to change a little bit. Incoming message, incoming message.
And now we have to put those fields.
To
Okay. Yeah.
message, nonce, VRS. Okay.
How nice of Copilot.
Yeah, that was nice. So from here, here's the incoming message. In fact, we probably don't even have to do that. We can just do this. It's the same. Look, incoming message.
Oh,
Just attach it, right? Just attach it. And then it goes out. Whoa.
Okay.
Ho, 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 ho. Now, I don't expect this to work, bro. So hopefully nobody else tries this right now. But I think we've covered all our bases for this identity stuff. So you and I are going to take this very, very slow. All right. We're going to take this very, really slow. I'm going to push this up. I know we missed something.
That was a lot of code changes.
I know. Yeah, there's a lot of code changes that we didn't test. Okay. First thing, pull that down, Kevin. And then we're going to do the make what? Run cap?
Well, I have to fix my files.
Yeah, I know. I'm going to run my cap. And then I'm going to run, what is it? Make run client. Okay. You're going to delete everything on your side. Yep. Delete all that. Delete your contacts. We're going to have to start over.
Okay, so Zarf is empty.
Zarf, yeah, Zarf can be empty. Now start your max run cap. Yeah, make run cap, right? Hey, did you pull latest?
Yeah.
Okay. So you should have a cap ID in there now in your Zarf folder.
Have a cap
Okay,
ID.
good. Now bring up your client.
And what was that? Make run
Client.
dash client.
Okay, I'm going to send you my, oh man, you can't copy and paste that?
Oh.
That's okay, I have it in my file, right? So hold on. Chat, Zarf, client.
See, I don't have the contacts directory.
You don't have a, no.
It didn't create it. Or cap ID, client. Oh no, okay,
Yeah,
it's
it's
in here.
there.
There it is, there it is.
All right. How do I send you that long ass value?
Slack it.
Oh, I can put Slack here on this side, so nobody sees my Slack. Yeah, nobody sees Slack here.
Yeah.
All right, Kevin. I shouldn't need yours because you're gonna send me
Yeah, so then now
a message and it should work.
No, that's the thing. That's weird. So now contacts. I don't know that. So I have to go to config and I have to add you.
Oh yeah, how do you?
And that was that.
That's why we kept the. That's why we kept
That's
the
why
thing.
we kept the thing there.
Okay, no big deal. Hold on. We're gonna put it back now too, right? But
Yeah.
hold on. We had commits that were today, right?
Yes.
All right. I just want to, actually, I should have done this. Okay, that was under chat, API, front end, I don't remember.
It was in a main, I think.
Oh, you think it was in main?
Yeah, we did it in a main. Yeah, there it is.
Okay. we're going to put this back in
Oh, Copilot kind of.
main. Hold on. Yeah, but no, that didn't match. Hold on. Let me copy this to you again. Now I know why. We need to add a note why I did that. Okay, I'll put that back in main too. But I sent that to you over Slack. Services. I mean, front ends.
Did you? Oh, no. Boom. Contact.
But now it's under, yeah, client.
Yes. Client/config.
Okay. And I will push that to. Sample starting config.
At some point, it might be worth adding, doing
Fake,
something on the UI, or
a
just
fake contact, right?
a placeholder, or just adding something on the UI to do it.
No, but we could do this. Like we could add, like the look.
Just have the structure there for placeholder.
Yeah. So let's just do that. Look, instead of doing this, when we create this for the first time, we'll do this again. Hold on. Contact. Right? When it's a create, new contacts, create config. Right? We just do this. But what we could do, zero x zero,
Mm-hmm.
just sample
Contact.
contact, right?
And 0.0 is red because it needs a common address.
So we do a common address like
empty.
that.
Yep.
So now let me push this code, because then you can do what you want to do. Here we missed that. Git stats, git commit minus am.
So now
Right.
I can delete all that again.
Yeah. Hold on. Creating sample contact. All right, pull that latest.
Git pull. Okay. So now if I do, what does it make? Run dash cat.
Let me escape and run you again. We don't have code that reconnects. Yeah, so now run your client.
Yep. Okay, because then when you run the client,
Now it should
one that-
create a space holder. Yeah, so that's fine. So now go into your thing,
yep.
go into your config, fix that, right? Change that to that ID that I gave you.
Yep.
Perfect. And then you can just restart your sort of client.
That was being nice. Oops.
Okay, so restart your client.
Yep.
And now send me a message. Okay,
Nice.
we just got a message
From anonymous.
from Anonymous. Hey, Bill, let me look at my chat Zarf client contacts. Oh, wait, no, it's my.
Hey,
Oh, yeah,
Bill.
yeah, that was the message there under UX. I wanted to look at config. Whoa, so that didn't work. So you didn't get saved, even though we created a.
No.
No, so we got to look at that code. And I didn't, right, it didn't get saved, so that sort of broke a little bit. But we're going to fix that right now. But the only way that message would have came across is if the signature checks worked.
Yes. So the signature checks work.
All right, let's take a look at that code again real quick. So on the client side, front ends, app, client, when we receive a message, which is right here, right? All this code here. No, that's handshake. Here it is right here. Look up contact. add contact, update contact, add message. So something here didn't work. Let's go to definition here. My guess is the contact wasn't found, right? And then we went into add the contact. And maybe this was in the wrong place. File name, I bet you.
Oh, because now we moved it.
File name is wrong. Yeah.
Because we moved that into client now.
It was supposed to... No, actually, file name was right because file name is config.json at the local path, and that's what I saved. So that should have worked. And then write config.
ID and then name.
Doc user. Write config. Oh, dude, we broke something here. When we did this piece, we broke something because the doc user
needs the name.
How does that even work? It says it wants a document. How is this even compiling? This wants a document. What am I missing here? You see what I'm saying?
Yeah.
Oh, read config. So here's the problem.
Returns a document. Okay.
I'm writing the config too early.
We need to write it after.
I need to write it after.
Okay.
Because I get the dot, we add it to the memory, then we added the contacts, but I was writing it before we did that.
Oh, okay.
Let's double check that that's the case. You're going to have to do it again.
Okay.
Send me another message. Okay, hey Bill, hello. Assuming that we did it right this time. Yes, there you are, anonymous. Now, what I don't like is it didn't.
It's not populating it. There.
Anonymous there, but it does say anonymous here, so we fixed that bug. That's good.
Yeah, it's not saying in the UI. It's not saying you like when you send a message.
Yeah, we probably broke that. So, yeah, it's also not saying you, right?
Yeah.
So.
No, it is actually. For me, it's saying it. It's just you haven't sent me a
I haven't sent a message yet, but the message coming in, that didn't work. So let's take a look at that. So this is the message coming in, right? Incoming message from, we looked it up. I updated it. Great.
From that name.
Add message here. So that worked. I got the message. Right? We wrote the hex and the message there, but this must be part of UI write. Let's see what happens on, UI write is a function that we wrote for the handshake.
And the handshake takes the name, which we set as blank, remember?
Yeah, so here it is, write text. So, write text.
What code was it that I'm thinking of?
Yeah, but no, I mean, this is the problem right here, okay? So, when we did the write text, let me leave this up. When we do the client here, let's go back, right? Before we do the write text, we set all this stuff up. So, when I come in here, we should have went down the default path. It didn't say ID not found. It said text message. Oh, I think we got rid of it. If ID equals current ID. Oh, then write the message. So the message itself was supposed to say it.
Because we did that format message. Yeah, message is assigned with format message username.
Ah, so
Yeah.
the username was then empty.
Yes.
The question is why. So let's take a look. Look up. Oh, I looked up the contact and you weren't there yet. You're not there
Oh.
until after I do this.
Well, if error.nil, well,
That's why. I mean, it's okay. So this is an easy fix, right? Because essentially, I'm going to get back a user.
okay.
So if I add you,
That means I wasn't there.
and then we update the context there, what I essentially need to do, and ideally it would be good for add contact, I think, to return a user. Yeah, this is what we should do. If you add a contact and we return a user, okay?
Mm-hmm.
So you have your doc user, you have all of that. And then it's just a matter of, I think a doc user,
ID name and message.
a collection of messages. Is that what a user is? Look up contact. And yeah, so we return the slice of messages, which is fine. Okay, so in this case, there are no messages. So I think we can do this. Look. We're done. Because we have a doc user,
Okay.
and then we can construct a user. It won't have any messages at that point.
Okay.
So now when we do
okay.
add contact, I do it this way.
The comma. Yep.
See, now we got a user. It reassigns it to this variable here,
Got it.
right? And now when we get to this point, we'll have the user. So now it's going to work because
We have a red there.
oh, if good catch. See, now the problem is it's going to work because if I hit escape and restart it, we should have found your name, unless I still, even if it's anonymous, it should have came up. So that should have worked for me when we first come in and load all the messages. So that's a different path. Let's take a look at that path. A.run. Run. Oh. Set root. How does that work when we first come up? We come in and we
Set change func with name.
read all the messages. Look up the contact. Oh, the problem is that the message didn't have your name in it.
No.
Yeah. Let me get rid of it. That's the problem. Okay, let's do it again. That bug is propagating itself because I was just reading the wrong messages.
Okay. Oh.
So let's do the following. Send me, I don't have you as a contact anymore. I'm going to get rid of you here too. Hold on.
Okay. Yep.
Let's try it one more time. Anonymous. See, that was the
Okay,
bug.
yeah.
I didn't do that. I got to save this one. Hey, Kevin.
Yep.
And it says Bill. And now I can come into my config and say this is Kevin. Right. All right. Let me
Got it.
save
Okay.
all this. That was we must have broke that at some point. Get stat. git commit, mine is just fixing just ID bugs. Okay, so what this now means is that make run cap. What time is it? Yeah, we're a little over. So now what this means, we have to we got to get it to reconnect too. We can now send messages, and there's no way for somebody to. We still got to deal with the nonce issue.
The nonce, yeah.
Okay?
Right now, the nonce.
And we need the
still...
accounting database, which is what we'll do on Friday. But at this point now, nobody can pretend to be you. Now we can test that, right?
Mm-hmm.
Watch. Let's do the following. So let's say I want to be you at this point.
Okay.
All right. So I go into Zarf. I go into client. Not my there, contact. Okay. So config. That's your ID, right?
Yep.
Now, watch what happens here. Actually, we'll see where the error shows up. It would have to show up. You're going to have to do this so I can see it in my logs.
Okay.
So what I want you to do, let me run this again here. What I want you to do is take my ID out of your thing. No. Leave it in the config. That's fine. Just
Okay.
make a copy of the ID.
Okay.
Okay. Now, hack your version of the client. So if you go into your version of the client where we send a message.
Where we send a read. What am I in right now?
Yeah, no,
Handshake.
yeah, right.
Send.
Send. Okay. You
Yep.
see where it says, oh, you don't send from.
No.
However, when you, okay, here's something that's
I
interesting.
have to change my ID.
It's part of the handshake. Let's look at the handshake.
Okay.
Because the handshake also should be validating a data message.
Mm.
So,
Yeah, ID, comma. address.
yeah, right? Because during the handshake, see, during the ID, you specify an ID that you are, right?
During
And we just take that.
Okay.
If you go into main.go and say that your ID is mine, see, you won't be signing with that ID.
App new ID. Because app new ID.
No. You have an ID file. Think about this for a second. You have an ID file.
So I just put my
During
ID
the
there.
handshake, you're saying who you are because under this new client, we take your ID. That means during the handshake, we send our ID over to them. This is who we are. Anytime I sign a message, we double check that the ID matches.
Okay.
So we don't have really time to do this, but if you hard coded my ID there, I don't want you to do it.
Okay.
If you had hard coded my ID there, it wouldn't match because you're signing everything with the other ID.
Oh, okay.
You see what I'm saying?
Yeah.
Like,
Okay.
so that would never match. So you'd never be able to sort of trick me there, even if you want to, because on the cap side, that's the ID that we save.
Yes.
So even if you said, this is my ID, you could never sign data using that ID.
Because we're doing those checks.
Because of that code that we added now, and we know is working because none of this messaging would have worked. But on the domain chat app, all that work that we did here,
Yeah, on the listen.
this, right?
Yes.
Like we know this works
That.
because that would have blown up.
Yeah.
And we get your ID at the beginning of the connection. So even if you were to hack if I was to hack my thing, it would have to show on the cap. Okay, so look, I can do that. Everybody can see this. Watch. So I know your ID, right?
Mm-hmm.
This is your ID here. Okay. So let's say I'm trying to be evil right now. I come into main, and what I do here is I say common dot parse that. Okay.
Okay.
Now that should
Return.
I want a common address dot I need to, how do I take this? Oh, here it is. Hex to address, sorry. So I do this, right? And I get Kevin ID. There it is. And I'm going to tell the system, I'm going to tell my cap that I'm Kevin. This is my ID.
Yeah.
Now watch what sort of happens now. I'm going to rerun that. I'm going to rerun my client. You don't even have to. Now it's me on the send side. Watch how the cap protects me here. Now, again, I could hack my cap, but this would happen everywhere, right? So I say, hey, Kevin. And look what happens here.
Signature does not match.
No, because I signed it with a different ID. So now my ID isn't the ID that I'm signing things with. And the cap just said, no, I'm not sending that over
Okay,
to
and,
Kevin,
I
right?
didn't get that.
No,
second.
you didn't get it. You didn't get it, right? Like, you didn't get this. Okay, because you dropped it. Now, this is the same thing that would happen cap to cap. Right?
Got it. Okay.
So you can see how we know that code is working because the ID checks aren't working now. So that was a cool little test to do, right? Because now we know, now it will work this time. I just got to restart it. So now I'm sending this, right? And that message stayed in history. Yo, this should work now. Because now I told the cap what my ID is.
Yeah.
And that's protecting everything there, right? And we're doing the same thing from cap to cap. We just don't have to do it back down. So we now have secure identification.
Yeah.
Nobody can send a message. They can pretend they're you, but nobody else can send a message as C273A82. Only you can, because you're the only one that can sign data. Mm-hmm. Right?
Got it. Okay.
And the cap validates those signatures, and we know who you are. And then from cap to cap, right? But now, could people try to hack things? Yeah, we could get it back all the way down to, if we pass the signature all the way back down to the client, then the client could also validate that this was you, right? Right now, I'm trusting the cap to do that. But if I was super paranoid, we could change it so the signature goes all the way down. And if we ever did peer-to-peer communication, we would need that. But we're not doing that. Everything's going over a cap.
Got it.
So, dude, we got this working, right? I mean,
It's cool to see that working.
thanks to the signature package that I had a whole bunch of code already. So we won't be back till Friday, but let's kind of take a look at where we're at now. So we have this, we have this. So what we need to do next, I had something in my head too, and I just forgot it. What we need to do next is the local accounting database. We need to keep track of what the last nonce was that somebody used.
And that'll be per cap.
No, that's per account.
Per account. Oh, okay.
That's going to have to be at this level here. So we're going to add a nonce to this record. Now, we're not going to be able to make sure that it's the next nonce number. Actually, we can do that. What we can do is if we track in here, if I track in here, yeah. So in my contact list, we're going to add a nonce field. Actually, this could be really cool. We're going to add a nonce field.
Okay.
And the idea is every time I send you a message, I got to use the next nonce.
So would that, so that wouldn't be tracked in contacts where we have our message history?
No, it wouldn't be, you don't track it here. I have to track it here. So I have to track that.
And that number's going to come.
But you've got to track it too, right? Mm-hmm. So on your side, when I send you a message, you're going to write to, no, but I also need, okay, there's going to be two things here. I need to know the nonce on both sides, right? So I'm going to need the send, we're going to need two things here.
The send and receive?
The send and receive.
Okay.
I think if we do this, so when I go to send you the next message, I've got to send you two. When I receive the next message, it has to be 2 in this case, right? So I'm going to keep track of the last nonce that I used to talk to you. You're going to keep track of the last nonce. I'm going to keep track of the last nonce I received. So we don't need a full accounting database. This is our accounting database right here.
Got it. Okay.
And if you ever send me a message that's not on the next nonce, I'm going to say no. Now, this is going to be tracked at the client level,
Okay.
right?
Yeah.
This is going to be tracked. So our signature will be checked at the cap level. But when I get the message, I already know the signature was valid. But if I don't see the next nonce, then I can throw this away.
Got it.
I don't trust it, right? Somebody has tried to send me the same message twice. Now, if these nonces get out of sync, we'd have to find another communication channel to talk over. But this would give us that nonce stuff.
Gotcha.
Right?
Okay.
Now, again, we could choose to also do signatures at the client level. I like doing signatures at the cap level because it will minimize any bandwidth we're using for evil messages,
Got it.
right? So if we say we can trust the cap to do signature verification, then we can do nonce verification here. And that's something you can even turn on and off if you wanted to,
Got it. Okay.
right? So I think that's what we're going to do. That's what we're going to do on Friday. So if I come back here, what we're going to do is essentially
Track nonce values.
values in the config, right?
Yep.
And this will be a client side. This will be a client side verification. So it will be a client side verification. There's also a nice check too, because if somebody did steal your key, well, they could look in your config. If they got your key, they got your config. They know what the next message is.
Yeah.
You got to track both sides. But at least nobody can send duplicate message, right? And then I could report on the screen, hey, dude,
Yeah.
what's going on, man? I think somebody hacked your account or something,
hacked.
right? Okay, so that we can do on Friday. There was something else that popped in my head and now I don't remember, but that's fine. So that would finish decentralized identification. I imagine we can do that very quickly on Friday. There shouldn't be much lift there. And then we'll have, this we have to really think about in terms of architecture, the encryption, because we're going to need a different key for the encryption. We're going to need like an RSA key. Again, not a big deal,
Okay.
right? So we'll use an RSA key for the encryption side, and then you got to basically share that public key. We're going to have to store it somewhere, maybe as part of the config for that user. We can store their public key in here. Public keys aren't that big, but we've got to send that public key. We don't want to send it wide,
Yeah.
right? And so I think in order to do encryption, since you got to send a public key, we need this first.
The private. Okay.
Yeah, I think we're going to need to do that first. We need to be able to establish a private stream between two people. So then we can send a public key, and then eventually we can send, right, an encrypted message would be the idea.
Got
But
it.
we'd have to do this first. Then we can establish encryption, right? So if we looked at sort of the order here, we got to be able to do a private temporary stream to do that. And then at that point, right, using the private temporary stream, we should be able to send an encrypted message between those two. Even though it goes on NATs, it doesn't matter, right?
Got it. Okay.
And then we can play with AI. So I think this is where we are sort of at. So we definitely can finish this Friday. I'm going to be traveling next week. So we're going to be doing something similar to what we did with David at NATS. I'm going to try to do this from where I'm traveling, and we'll see where we're at. Let me, and I'm sorry we didn't share our screen. Man, I totally forgot about that in the beginning of this session, didn't I? And everybody was screaming at me, and
No, me too. I was focused on the window.
I know, we were so focused on this. This happens when I'm in the studio all the time, and Eric's got to yell at me, hey, share screen, share screen. Oh, I'm on the wrong side here. And I forget to do that, so. But we have decentralized identification now. Nobody can spoof who you are unless they get your private key. We'll do the nonce stuff next week. So we got to increment that nonce. We record it, we increment it, we know what the next nonce is.
Yep.
And both sides can verify that you're using the right nonce. That gives us the next level of sort of security. We'll do that at the client level. I think that's fair. Then we really got to think about private streams, bringing them up, breaking them down. If we can get the private, temporary, transient stream going, then
from there we're in business.
I just don't want to leave. We got to be able to clean up after ourselves, which is the problem. And it can't be, the name of the stream can't be something that can be reproduced by somebody.
Got it.
Yeah,
Okay.
right. So we're gonna need a way of some hash or something that is. That might be interesting. You know, it would be cool if we find a way where it's random but known to both of us, like Ethereum does. Remember I told you in Ethereum where they're trying to figure out who's the next one that's going to do the work.
Everyone has to agree.
So everybody looks at the data on the last block, and you run an algorithm against the data on the last block, and that gives you an idea that tells you who to do it.
Yeah.
So it's random in the sense we don't know who it's going to be, but everybody on the planet gets the same answer. If we could do that with our config. So once we have nonces in there, right?
Yeah.
Once we have nonces in there, we might be able to leverage data in the config that only we know, which would generate the name of the stream.
Okay.
Because we each gotta need to know what the name of the stream is.
Yeah.
And that has to happen in a very secret way. We don't want somebody else connecting to it. So we're gonna have to do that. We're gonna have to come up with an algorithm that reads the data in the config that only us should know about. Our nonces, again, become really important,
Yeah.
right? And then based on that data, we can generate a random string value that nobody else on the planet could figure out what it is because they would need that data, which means that stream changes every time we also use it, which is important. So we're going to leverage some of those Ethereum ideas for the temporary stream. So we're going to have to, you know what? Right before we quit here, let me just do this, right? So we got to generate the stream name based on config data. So we're going to have to do this because the moment somebody else knows that stream, they can connect to.
They can connect to it.
Now, again, it will be encrypted. But that initial time when we want to establish something, well, let's think about it. There's architecture that has to go on.
Got it.
But,
Okay.
And maybe the thought is it doesn't matter. But I don't want to lose the thought that I just had here. So let's at least do that. Anyway, we're way over, so we're going to end this thing. But I think it was a pretty good day. We've got a pretty nice system that's sort of running now, so that's pretty good. If I just look quickly at any notes here, all right, no necessarily questions, but sorry about the beginning of the stream, but all right, so we're out. We'll see everybody again on Friday. I can't be back here till Friday, but we'll finish that initial work on Friday. Bye.